Mike 0.
This is Oscar Mike 0 Echo Tango QRP.
Echo Tango QRP, what is your power?
I'm running only 5 watts and a dipole antenna homemade, over.
Come on, you're 5 and 9. Over the pilot. Hotel 5.
Another contact to Greece. And I beat the pilot actually. Amazing. Hello friends, I'm Paul, Oscar Mike 0 Echo Tango. We are going to transform balanced dipole antenna fed in the center to the unbalanced feed line, as is the coaxial cable. And therefore we have to make this 1-to-1 balun for it. So just let me overview this little transformer. I am using here the ferrite toroidal core, which is FT8243, which is a very small ferrite, capable work maybe 20, maybe 50 watt of power. So it's not 100% for 100 watts or even more. So maximum 50 watts is my recommendation. I'm using 0.5 millimeter thick wires, as you can see, that 2 colors, and the length of each wire is 35 centimeters each. 35 centimeters each, and you need 4 35 centimeter each wires. So you need to wrap twice these wires on one side, and also twice those wires on the second side. As you can see, on the beginning you're starting with the red wire on the left and the blue wire on the right. That way you are doing actually 12 turns across the half of this toroidal core. After 12 turns, you secure this wire here on the toroidal core. Next, you're doing the second half of this toroidal core, ferrite core. So you begin with the blue wire on the left, red wire on the right. So you see that it's quite opposite. So that way you are doing 12 turns across the second half of the core. Also, you have to secure it on the beginning, on the end. I have to mention that one turn counts when the wire is coming through this hole, actually. Yeah, if the wire is coming through the hole, that counts as a turn. So therefore you need 12 turns here, 12 turns here. You see that the colors are opposite, so the red colors is in the middle, but on the end the red color is on the sides and the blue color is in the middle. That is the basics on the 1-to-1 unun. Next, we have to do one thing. You need to connect together each colors. So here and here. And also the same thing here on top. You need to collect red colors together to the one side and blue color to the second side. It's very simple actually. Good. And now this transformer is ready to be mounted into some kind of enclosure. You can find any kind of enclosure as you wish. So let me explain how you connect this transformer in it. So here on the bottom, for example, the red one, I will connect to the center pin of coaxial cable. So if I show you connector, let's say BNC connector for QRP purpose. So here will be connected the red one, and here will be connected the blue one. That is fine. And here will be connected one quarter wave length of the dipole, and here the second quarter wave of the dipole. Actually, that way you can make half wave dipole for the band you want to make. I have to pre-solder this soldering eye because I don't want to overheat the plastic inside the box. Here is all what I need. So BNC connector. If you don't like the BNC connector, you can use the SO239. Then two eyes for mounting and tighten the antenna wire. We need two screws for connection to antenna wires and some stuff around. Also soldering eyes for these screws and connection between these screws and transformer wires. Some bolts and some other stuff. All the holes I made are 5mm wide, so I'm using a 5mm drill, and also all the bolts and screws are 5mm, so M5 is the size of the screws or bolts. And here will be connected a dipole or the wires for the dipole. So here's some washers and soldering eye for the next antenna wire, and all this is secured by the other washers and butterfly screws. So my design is here that this is for tighten the wire. All the pressure from both wires will be here on those bolts, and the eye coming from, or the wire coming through the eye will come in here, will come to this screw, and also here. The isolation layer have to be taken down because I need to solder the ends to the connector and also antenna terminals. And it's very good to pre-solder these wires before its installation into the enclosure. And the same thing I have to do here on the second end of transformer. And there is also my advice, you better use a longer wire, because especially when you're using a larger enclosure like me right now, so I have to use this longer wire. So I would recommend to use maybe not 35 centimeter long wires, but maybe 40, maybe 45 centimeter longer, better of course. So therefore I had to scratch this layer here in the middle of the longer wire, and here I will twist this wire along this longer wire and solder them together. So the same thing I have to do here, and I will put some heat shrink over here, and this end I connect to the antenna terminals. So as I told you, I twisted both wires together, solder it, and here is a little heat shrink. Put it over here, and it is actually done. Good. So now this transformer is ready to put it into this enclosure I prepared. And finally, I have cut this wire to its specific length I need to reach this bolt and soldering eye, and I can finish this construction by soldering this eyes to the wire. Perfect. So antenna transformer is finished and hopefully ready to work. There is also seal in this enclosure, which makes this transformer rain proof or weatherproof. And also you can put some silicone in here or some kind of glue to fix this transformer. All right, Perfect, and we're done. Transformer has been finished, so here is the place for the antenna wires, and tighten these antenna wires to these eyes. The leftover of the wire will come here into these antenna terminals. As you see, these wing nuts are here. Also the soldering eye for the wire. As you can see that there are two washers in between this wing nut and this nut, and an eye I used right in there in the middle. So that is how it should work in my case. So let me test this balloon. Welcome to my garden. I'm going to test my new 1.1 balloon. As you can see, this antenna installation here on this side is 2.5 or 2.3 meter long wire. The same wire is here on the right side of the antenna. This balloon is currently only about 1.6 meter maybe up from the ground, and down there you can see the mini 1300 antenna analyzer, which I currently set to 10 meter band. So here you can see 10 meter band between 28 and 29.7 megahertz. So let me show you what the SWR like here on this band. As you see, that SWR is pretty good. 28.595 is a resonant frequency, or 28.6, and the SWR is 1.1. So definitely this balloon is working properly. Of course, I can show you the frequency or bandwidth of this antenna. So here we are looking on the lower part of 10 meter band, which is 28 megahertz, and SWR is below 2. Then below 2 on the upper side is somewhere around 29.300. So this antenna is workable within 28 megahertz and 29.300. Of course, on these higher frequencies you will need to use a tuner, but it's still very good. So here we can see other parameters like impedance of this antenna. Also here we can see reactance and other stuff, R and X, and S11, which is the resonant frequency here, and Smith chart looks like this. Good, and next test will be this antenna on 20 meters. I just added one more radial and prolonged the radial to other I'm not sure, maybe 2.5 meter long wire, and the same wire is added to the other side. So antenna now is tuned for 20 meter band. So let me show you how it looks like on the antenna analyzer. So here we can see 20 meter band, and from 14 to 14 and 350. As you see that the SWR is perfect around 14,206, and SWR is 1.1. As you see that the bandwidth is pretty wide. In actually whole band you can work without tuner, which is 1.5 on the beginning and about 1.5 on the end. excellent. This is really ideal. So this antenna is currently, as I told you, about 1.6 meter above the ground, just for my testing, of course. So I connected my Zygo 6100 to my dipole for testing. I have 20 meter band and check the SWR, and you can see that it is ideal. There is no really big SWR here, between 14 and 14,600. So SWR looks good on 20 meters.
Victoria 3, Charlie, Norway, Zulu. Beaming Asia calling CQDX. Italy, Victoria 3, Charlie, November, Zulu, over.
A QRP station.
Yes, I listen, you go ahead.
Thank you. Just for a short test, this is Oscar Mike 0 Echo Tango QRP 5 watts QSL.
Oscar Mike 0 Echo Tango. Good evening, nice to meet you. You're 5'9 plus.
Whoa.
Very strong with QRP. What is your antenna, over?
Well, I'm testing my homemade dipole, only a dipole, but 1.6 meter over the ground, just for testing, over.
Yes, copy, very good. 5'9, 10 dB QSL.
Wow, cool. Thank you very, very much for the nice report. You are 20 dB over 9 here in my location. Thank you so much for the QSL, and 73 over.
Okay, 73, good luck, good evening, and thank you to you for the call. 73.
Thank you, bye-bye. That was really cool. 10 dB over with 5 watts and dipole antenna. Cool. Into Italy, of course.
Mike 0.
This is Oscar Mike 0 Echo Tango QRP.
Echo Tango QRP, what is your power?
I'm running only 5 watts and a dipole antenna homemade, over.
Come on, you're 5'9, over the pilot. 73, good luck.
Thank you so much, and 73, good luck.
Hotel 5.
Another contact to Greece, and I beat the pilot actually. Amazing. Amazing. Alright guys, so I think that the real tests with the radio are the best when you're testing any antenna. Anyway, this is just a prototype antenna, so I plan to make another type of the mini unun, but this will be mini balun. For the next informations, you can go down into the video description, and I will put the link when this product will be finished. 7-3 guys, thank you very much for watching.